press the bell icon on the YouTube app and never miss another update.
Good morning, my dear students. Today we are going to discuss with the chapter chemical bonding. Generally, atoms are less stable in nature. In order to attain the stability, atoms which are not present in a single manner, they always undergoes grouping. Means usually the atoms are unstable in nature or less stable in nature. In order to get the stability, the atoms which combine with each other and they undergoes grouping. In those grouping which exist as a chemical species, and those chemical species which we can call them as molecules. In order to get the stability, atoms undergoes combination or atoms undergoes grouping, and those grouped species we can call them as molecules. As we already told, atoms undergoes grouping, and those grouping of atoms and those species we can call them as molecules anta. And these grouping of atoms, in those group different atoms are present. All the atoms are exist, or all the atoms are combined together by some sort of attraction. ಯಾವುದೋ ಒಂದು force all the atoms ಅನ್ನ combine ಮಾಡಿರುತ್ತೆ. And what is that force is called? All that atoms which are combined in that particular force, with that force they are all are binding, that force we can call it as a chemical bond. The force of attraction which holds all the constituents, the force of attraction, the force of attraction which holds constituent particles, which holds constituent particles. Constituent particles ಯಾವ್ಯಾವ್ದಾಗಿರುತ್ತೆ? Either they may be atoms, either they may be ions. Okay, constituents together in a different chemical species, in a different chemical species, different chemical species is called, different chemical species is called chemical bond. Chemical bond. Okay, ನಾವು ಹೇಳಿದ್ವಿ atoms ಲೆಸ್ ಸ್ಟೇಬಲ್ ಇರುತ್ತೆ. ಅವುಗಳು ಸ್ಟೆಬಿಲಿಟಿನ ಅಟೈನ್ ಮಾಡೋದಕ್ಕಾಗಿ ಅವೇನು ಮಾಡ್ತವೆ? ದೇ ಅಂಡರ್ಗೋಸ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗೋದಿಲ್ಲ. ದೇ ಅಂಡರ್ಗೋಸ್ ಗ್ರೂಪಿಂಗ್ ಆ್ಯಂಡ್ ದೇ ಎಕ್ಸಿಸ್ಟ್ ಆಸ್ ಅ ಮಾಲಿಕ್ಯೂಲ್ಸ್. ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳ ಸ್ಟೆಬಿಲಿಟಿ ಆಟಮ್ಸ್ ಸ್ಟೆಬಿಲಿಟಿಗಿಂತ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಆ್ಯಂಡ್ those atoms, group of atoms which are held together by some sort of force, ಯಾವುದೋ ಒಂದು ಫೋರ್ಸು ಆ ಎಲ್ಲ ಆಟಮ್ಸ್ಗಳನ್ನ ಬೈಂಡ್ ಮಾಡಿ ಇಟ್ಕೊಂಡಿರುತ್ತೆ. ಆ್ಯಂಡ್ that force we can call it as chemical bond. That is the force of attraction which holds the constituent particles, either they are atoms or ions, together in a different chemical species. The species may be anything. In a different chemical species, all the atoms are adjusted together, all the atoms are attracted together by some sort of attraction, that we can call it as a chemical bond. Okay, if we take an example of formation of hydrogen molecule, formation of hydrogen molecule. How do the hydrogen molecule is going to be formed? If you take two hydrogen atoms, what is the atomic number of hydrogen here? Atomic number of hydrogen is 1. It is having the configuration of 1s1. Both the hydrogen atoms are having the configuration 1s1. After the formation of bonding, these two hydrogen atoms, as we already told that atoms in an independent state, they are unstable in nature. In order to get the stability, these two atoms combine together, they form a hydrogen molecule. There is a formation of a bond takes place between these two atoms. While the formation of a bond, what is the reaction takes place here? During the formation of a bond, some amount of energy is released na formation of bond aguvaga energy release ಆಗ್ತದೆ. With the release of energy, energy of this whole molecule decreases. As we know that energy and stability of the molecule, energy and stability are inversely proportional with each other. These two things are inversely proportional with each other. If the energy of the molecule is increases, at the same time stability of that molecule is to be low. If the stability of the molecule is more, means that possess a less amount of energy. Like that, here these two atoms which are independent in nature, which are less stable in nature, in order to get the stability they undergoes combination and they will become a hydrogen molecule. In this state the stability of the molecule is more. Here this possesses less energy. With the liberation of energy which possesses less energy ಇದೆ ಅಂದ್ರೆ ಇದರ ಸ್ಟೆಬಿಲಿಟಿ ಹೆಂಗಿರ್ತದೆ, which is more stable in nature, which is more stable in nature. And what about this? These are atoms which are having higher in energy, that means which are possess higher energy and which possess low stability. Okay, in order to get the stability, in order to increase their stability, the atoms undergoes combination. Okay, here some of the doubts that arises regarding this concept, regarding the combination of atoms. What are those doubts? What is the need of a combination of the atoms takes place? Atoms individual agi exist agutte or individual agi exist agodilla. In order to get the stability, atoms combine agutte anta helidvi. Then what is the need of combination of atoms? This is the first step. Why do the atoms get combined? Second one, in some cases only some certain atoms are combined together with some certain atoms, means there is some certainty is there in between the combination of atoms. Only certain combinations are possible, and why can't the other combinations of atoms is not possible? This is the second point. And first we will go with the atoms combine with each other. Why do the atoms combine with each other? ಯಾಕೆ atoms combine ಆಗುತ್ತೆ ಅಂತ ನೋಡೋಣ. ಯಾಕೆ atoms combine ಆಯ್ತು? ನಾವು ಆವಾಗಲೇ ಎಕ್ಸಾಂಪಲ್ ಅಲ್ಲಿ ನೋಡಿದ್ವಿ, atoms combine together in order to get the stability. That is the major one, that to get stability. To get stability is, this is the first point. Why do the atoms combine each other antandre? In order to get the stability. And one more thing it is, in order to get in order to attain the stable electronic configuration. Why do the atoms combine with each other antandre? In order to attain the stable electronic configuration. Stable electronic configuration andre yavadu? ನಮ್ಮ ಪೀರಿಯಾಡಿಕ್ ಟೇಬಲ್ ಅಲ್ಲಿ ಸ್ಟೇಬಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ಸ್ ಮೇಜರ್ಲಿ 2 ಕಾನ್ಫಿಗರೇಷನ್ಸ್ ಬರುತ್ತೆ. ಒನ್ ಕಾನ್ಫಿಗರೇಷನ್ ದಟ್ ಈಸ್ ಆಕ್ಟೇಟ್ ಕಾನ್ಫಿಗರೇಷನ್ and the second one it is a duplet configuration. Octet configuration and duplet configuration. Okay, what is meant by this word octet configuration? Octet configuration antandre, any molecule or element if it possesses 8 electrons in its valence shell, 8 electrons in its valence shell, 8 electrons in its valence shell ಆದರೆ ಇದನ್ನ ನಾವು octet configuration ಅಂತ ಕರಿತೀವಿ. And this will be the most stable configuration of molecules and elements. And the second configuration, if in case of elements whose atomic number less than 8, ಅವುಗಳ atoms ಅಲ್ಲಿ ಆ elements ಅಲ್ಲಿ atomic number less than 8 ಇದ್ರೆ which do not possess this octet configuration, ಆಗ ಏನು ಮಾಡಬೇಕು? Those molecules or those elements which possesses this configuration, that is called a duplet configuration. Okay, duplet configuration means 2 electrons. If the molecules are an elements if it possesses two electrons in their valence shell. Two electrons in their valence shell means that represents the duplet configuration, means both these configurations are stable configurations, either octet configuration or duplet configuration. Okay, ಇಲ್ಲಿ ಏನು ಗೊತ್ತಾಯ್ತು ನಮಗೆ atoms, what is the necessity of combination of atoms ಗೊತ್ತಾಯ್ತು. Why do the atoms combine each other? Atoms combine each other in order to attain the stability and in order to gain the stable electronic configuration. Stable electronic configuration ಯಾವುದಿರುತ್ತೆ? The first one, it is either it should attain octet configuration or it should go with the duplet configuration. ಇವೆರಡು ಕಾನ್ಫಿಗರೇಷನ್ ಅನ್ನು ಅಟೈನ್ ಮಾಡಿದರೆ ಆ ಆಟಮ್ ಅನ್ನ ಅಥವಾ ಆ ಎಲಿಮೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ ಅನ್ನು ನಾವು ಸ್ಟೇಬಲ್ ಎಲಿಮೆಂಟ್ ಅಂತ ಕರೀತೇವೆ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ we'll go with one more example, that is formation of a NaCl molecule. If you consider, if you take an example of sodium, what is the atomic number of sodium here? Atomic number of sodium is 11. Okay, and it is having the configuration 1s2, 2s2, 2p6 and 3s1. Okay, in short I can write it as 281. It is having this much of configuration. Here this 1s2, it belongs to K shell, that means that will be the ground shell, and 2s2, 2p6, this becomes L shell, and this 3s1, it will become the M shell and it acts as the valence shell. Valence shell ಅಂದ್ರೆ last shell of the configuration ಯಾವುದಿರುತ್ತಲ್ಲ ಅದನ್ನ ನಾವು valence shell ಅಂತ ಕರೀತೇವೆ, and the number of electrons present in this valence shell are called valence electrons ಅಂತ ಕರೀತೇವೆ. And during the chemical combinations, these electrons, that means electrons present in the inner shell which do not take part in a chemical reaction, while the electrons present in the outermost shell which can readily involve in the chemical combination, because the electrons present in the valence shell are less tightly held by the nucleus. In this nucleus, these electrons, that means electrons of the inner shell, are tightly held by the nucleus, followed by the electrons of the outermost shell, that means the valence shell electrons, they have less affinity towards the nucleus, so that they can easily involve in the chemical combination. Okay, here sodium, this will be the configuration. Okay, in a 281, if this sodium, if it loses this one electron from this shell, if it loses its one more electron, then it will become a 28, that means ns2 np6 configuration, that is octet configuration and attain ಮಾಡುತ್ತೆ. That is why sodium is always ready to donate this one electron and to get the stable electronic configuration. Stability na attain ಮಾಡಲಿಕ್ಕೆ this sodium is always ready to donate this electron. Okay, at the same time chlorine atom, atomic number of this one is 17. It is having a 287 configuration. 287 configuration, that means this will be the K shell, L shell and M shell. In the last valence shell, it consists of 7 electrons. 7 electrons ಅನ್ನು ಹೊಂದಿದೆ, and these 7 electrons are called valence electrons, and these are ready for the involvement in a chemical combination. Okay, here 287 it is, that means this chlorine atom which requires one more electron to get the stable electronic configuration. Okay, if this one electron given by this sodium atom is accepted by this Cl atom, then it should attain the stable electronic configuration of 288, that will be the stable electronic configuration. That is why atoms, they combine each other in order to attain the stable electronic configuration. Stable electronic configuration. Okay, atoms ಗಳು ಕಂಬೈನ್ ಆಗುವ ಮೂಲ ಉದ್ದೇಶ in order to get the stability, and second one, in order to attain the stable electronic configuration, either it may be octet or it may be duplet, but it must be a stable electronic configuration. Okay, Is it clear with the definition of chemical bond and what is the need of a combination of atoms? Okay, let us move on to the next concept, that is valency. Valency means it is the combining capacity of an element. Valency is the combining capacity of an element, of an atom in an element is called valency. Atoms, if you take an example of hydrogen, atomic number is 1, it is having 1s1 configuration. Here hydrogen, in order to attain the duplet configuration, means nearest noble gas configuration yaudide andre helium irtade. Helium is having nearest noble gas, that is having 1s2 configuration. Okay, in order to attain the configuration of nearest noble gas, hydrogen require one more electron. In order to attain that electronic configuration of helium, this hydrogen atom, it tends to attract that one electron, or it tends to gain that one electron from any other species, and it will become a 1s2. So this tendency of atoms either to lose the electrons or to gain the electrons or to share the electrons with the other atoms in order to get a stable nearest noble gas configuration, adu enide adanna ನಾವು valency ಅಂತ ಕರಿತೇವೆ. ಯಾವ atoms nearest to noble gas configuration ಅನ್ನು attain ಮಾಡಲಿಕ್ಕೆ either they can ready to lose the electrons or they can accept the electrons or they are ready to share their electrons with the other atoms ಇರುತ್ತಲ್ವಾ, ಆ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು ನಾವು valency ಅಂತ ಕರಿತೇವೆ. Here hydrogen, it requires one more electron, that means valency of hydrogen is 1. Valency of hydrogen is 1. Here helium, it is already completely filled configuration 1s2, it is having duplet configuration, that means valency of helium is 0. ಇದಕ್ಕೆ ಯಾವುದೇ ರೀತಿ ಎಲೆಕ್ಟ್ರಾನ್ಗಳ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ಯಾಕೆಂದ್ರೆ it is already completely filled in nature. Okay, then we'll go with carbon. What is the atomic number of carbon here? Atomic number of carbon is 6. It is having configuration 2 4. Okay, in order to complete their shell, it requires 4 electrons. 4 ಎಲೆಕ್ಟ್ರಾನ್ಗಳ ಅವಶ್ಯಕತೆ ಕಾರ್ಬನ್ನಿಗಿದೆ. That is why it accepts those 4 electrons in the form of mutual sharing. ಮ್ಯೂಚುವಲ್ ಶೇರ್ ಅನ್ನು ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಈ 4 ಎಲೆಕ್ಟ್ರಾನ್ಗಳನ್ನು ಬೇರೆ ಆಟಮ್ಸ್ಗಳಿಂದ ತಗೊಳುತ್ತೆ. ದಟ್ ಈಸ್ ವೈ ವೇಲೆನ್ಸಿ ಆಫ್ ಕಾರ್ಬನ್ ಈಸ್ 4. Like that, in order to attain a stable electronic configuration, either to attain duplet configuration or to attain a octet configuration, different elements they undergoes, or they are ready to accept the electrons, or they are ready to donate, and they are ready to involved in a mutual sharing of electrons only to get a stable electronic configuration. Okay, this is the concept of valency. Next, the next concept is valence electrons. Valence electrons. Is this both the concepts are same? No, the concept of valency is different from valence electrons. It is regarding the accepting or donating the number of electrons in order to get the stable electronic configuration, but it is regarding the valence electrons, means the electrons present in the last shell or valence shell of any element is known as a valence electrons. Electrons present in the valence shell are called electrons present in the valence shell are called valence electrons. Electrons present in the valence shell are called valence electrons. Okay, if you take an example, again if you take an example of hydrogen, it is having only one electron, that will be the valence electron of hydrogen. If you take an example of a carbon, atomic number of carbon is a 6. It is having configuration 1s2, 2s2, 2p2. This will be the ground state of carbon, means the electron is present in the K shell, and the next one it is a 2s2, 2p2. This is the next shell of carbon atom. That means L shell will be the valence shell of this carbon atom, and this valence shell which contains how many electrons here? Which contains 4 electrons here. That means the valence electrons present in a carbon are valence electrons of carbon are 4. That is why we can call the carbon as tetravalent. How many valence electrons it is having? In the last shell it possesses 4 electrons, that is the valence electrons present in this carbon are 4. If you take an example of nitrogen, atomic number of nitrogen is how much? It is 7. Okay, then the configuration of nitrogen is 1s2, 2s2, 2p3. Again, this 1s belongs to the K shell, and this 2s and 2p belongs to the L shell. This will become the valence shell, and this valence shell consists of how many electrons? This valence shell consists of 5 electrons. It is so that the valence electrons of nitrogen are 5. It possesses 5 valence electrons, right? This will be the electronic configuration. This is the ground state 1s2, 2s2, 2p, 3 is the second state, or it will be the final state. That means this is the valence shell of a nitrogen atom. This valence shell which consists of how many electrons? 3 plus 2, 5 electrons. That is why valence electrons of nitrogen are 5. Okay, and these 5 electrons and these 4 electrons, they are always ready to involved in a chemical combination. As I already told, electrons of the valence shell, last shell alliro electrons enirutte, they are always ready to involved in a chemical combination. Chemical reactions alli involve agalikke these electrons present in the valence shell are always ready. Okay, next if we go with the oxygen, what is the atomic number of oxygen? You can take 1s2, 2s2, 2p4 is the configuration of oxygen. Okay, in the first shell again it contains 2 electrons. In the valence shell it consists of how many electrons? In the valence shell it consists of 6 electrons. Valence electrons of oxygen atom is 6. Like that, if we can take the example of a chlorine atom, atomic number of chlorine is 17. In short form I can write it as 287. It is having this configuration. In the first shell, ground shell, it consists of 2 electrons. In the next shell, which consists of 8 electrons. In the last shell, that means the valence shell, which consists of how many electrons? It is 7 electrons. This is K shell, L shell, M shell. M will be the valence shell of chlorine atom. Then this M shell, which consists of how many electrons here? 7 electrons. That means in a chlorine atom 7 electrons are ready for involvement in a chemical reaction or chemical combination. That is why valence electrons of chlorine atom is 7. Like this, the concept of valence electrons. I repeat the definition of valence electrons. Electrons present in the valence shell of a element, we can call them as a valence electrons. ಯಾವುದೇ ಎಲಿಮೆಂಟ್ ನ ಲಾಸ್ಟ್ ಶೆಲ್ ಅಲ್ಲಿ ಇರತಕ್ಕಂತ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಗಳು valence shell ಆಗಿರುತ್ತೆ, valence shell electrons ಆಗಿರುತ್ತೆ, and those electrons are always ready to involved in a chemical combination. These are the examples for the valency of different elements. Okay, is it clear with the valency and valence electrons? Valency means it is the combining capacity of an element where each atom is always ready to accept the electron, always ready to donate or to involve in a mutual sharing with the other atoms, only to attain a stable electronic configuration. That will become a valency, and valence electrons means electrons present in the valence shell. Is it clear? Yes. Next, the next concept is that will be octet rule. octet rule. What is meant by this word octet rule? Octet rule means if you consider sodium atom and a Cl atom. What is the atomic number of sodium atom here? Atomic number of sodium atom is 11. At the same time, atomic number of Cl is 17. If you consider the electronic configuration of sodium atom, it should have a 1s2, 2s2, 2p6, 3s1 configuration. Total it is having 11 electrons. In the valence shell, this will be the first shell, and 2s 2p6 will be the second shell, and 3s will be the third shell. In the third shell, that means in the valence shell, this sodium atom should possess how many electrons? It possesses only one electron. Okay. At the same time, this Cl atom atomic number is 17. It is having the configuration 287. That means 1s2, 2s2, 2p6, 3s2, and 3p5 configuration it is having, in which this will be the K shell, this will be the L shell, and this will be the M shell, where in the last shell it consists of how many electrons? Which consists of 7 electrons here. This chlorine atom, which requires how many electrons to get the stability? 2, 8. If it requires only 1 electron, if we add 1 electron into this chlorine atom, it will attain the stable configuration of 288. In order to become 288, for chlorine, 1 atom or 1 electron is required. Okay. For sodium atom, here it is having the configuration like this: 2, 8, 1. Okay. In order to attain the stable electronic configuration, octet configuration in this sodium atom which is having 1 electron in excess. Here it is which possesses 1 electron in excess. That is why sodium is always ready to donate this 1 valence electrons. Okay. In order to get a stable electronic configuration, sodium is always ready to donate 1 electron. At the same time, for the same purpose, in order to get the stable electronic configuration, this Cl atom always ready to accept 1 electron. That is why this sodium always ready to donate this 1 electron, and it will become Na plus 1 electron. And now what is the configuration of this sodium? It is again 281. It is after losing the 1 electron in this sodium ion state, it will have a 2,8 configuration with the loss of 1 electron. Now it is in a stable configuration. Stable configuration of sodium is 2,8 now, Na plus state only. At the same time, Cl atom which requires how many electrons to get the stability? Here the configuration of Cl is 287. After getting this 1 electron, it will become a configuration Cl minus it is. Okay, next it will attain the configuration of 288. This will be the next configuration of Cl minus, and this will be the stable electronic configuration of Cl atom. Okay, likewise, in order to attain the stable electronic configuration, atoms they undergoes, or they are ready to accept the electrons, they are ready to donate the electrons. At the same time, the atoms they are ready to involved in a mutual sharing with the other atoms. This concept is known as a octet rule. Okay. Exact definition of octet rule is nothing but atoms attain atoms can attain nearest noble gas configuration, nearest noble gas configuration either by the complete transfer of electrons, either by the complete transfer of electrons from valence shell of one atom to the valence shell of other atom, or by the mutual sharing of electrons. Mutual sharing of electrons in order to get octet octet is called octet rule. Okay, now you got the point. Atoms here, sodium is an atom, chlorine is an atom, both are ready to donate the electrons, and this Cl atom is ready to accept the electrons. For what purpose this can take place? Here the only purpose is to attain the stable electronic configuration, that is here sodium, after losing this one electron it will gain a stable electronic configuration of 2H, and after accepting one electron, this Cl atom, it will become Cl minus, and it will attain the stable electronic configuration of 2H8. Okay, adana helidare atoms can attain nearest to noble gas configuration either by the complete transfer of electron from valence shell of one atom to the valence shell of another atom. This will be the valence shell na KLM shell, and this will be the valence shell na KLM, valence shell of one atom to the valence shell of another atom. The transfer of electrons takes place in order to attain the stable electronic configuration, that is called a octet rule. Here one more thing it is there, that is mutual sharing. What is meant by this mutual sharing? If in case of CH4, if you take an example of a CH4 methane molecule, in case of a carbon, what is the atomic number of carbon here? Atomic number of carbon is a 6. 6 means how can we represent like this? 1s2, 2s2, 2p2. Okay, we can represent the carbon in electronic configuration like this: 1s2, 2s2, 2p2. This 1s2 will be the K shell, that means that will be the ground shell, and 2s2, 2p2 will become the valence shell of carbon atom. How many number of electrons are there here in carbon atom? Here we have 4 electrons. That means carbon is a tetravalent in nature, and these 4 electrons are always ready to involved in a chemical bonding. But here in short form I can write it like this. Here the shell, which consists of 4 electrons, it has both the possibilities. The first possibility, it can lose its 4 electrons and will become a configuration of helium. Configuration of helium is how much? It is 1s2 na. If this carbon atom, if it loses its 4 electrons, then it will attain the stable electronic configuration of helium. That is the first possibility. Second one, if we add another 4 electron into this shell, ಇದೇ ಶೆಲ್ಗೆ ನಾವು ಇನ್ನೊಂದು 4 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ಆಡ್ ಮಾಡಿದ್ರೆ ಅಗೈನ್ ಇಟ್ ವಿಲ್ ಬಿಕಮ್ 2 8 ಆಗ್ತದೆ. ಬಟ್ ಹಿಯರ್ ಬೋತ್ ದ ಪಾಸಿಬಿಲಿಟೀಸ್ ಆರ್ ನಾಟ್ ದೇರ್. Carbon, it neither loses its 4 electrons and nor it gains 4 electrons to get the stability. ಯಾಕೆ ಅದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ಕೊಡೋದು ಇಲ್ಲ, ಯಾಕೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ತಗೊಳ್ಳೋದು ಇಲ್ಲ ಅಂತಂದ್ರೆ, here in order to lose 4 electrons, if the carbon wants to lose this 4 electrons, means for a removal of each and every electron we need to apply the energy. Okay, that is why in order to remove this 4 electrons we have to supply more amount of energy. More amount of energy is required na. That is why this is not possible. One way it is not possible. Which is the second way? Second way is to add 4 electrons into this shell. ಈ ಶೆಲ್ಗೆ 4 electrons ಅನ್ನು ಆಡ್ ಮಾಡಬೇಕು. So after the addition of 4 electrons into this carbon atom, what will happen? This carbon is left with 6 protons na. Protons ಅಲ್ಲಿ ಯಾವುದೇ number of changes ಆಗೋದಿಲ್ಲ, protons remains as it is. But after the addition of 4 electrons into this shell, the total number of electrons in carbon becomes 10, but the total number of protons, it remains as it is, it remains as a 6. That is why possibilities of both the cases, either to lose the electrons or to gain the electrons in order to get the stability, is not possible for a carbon atom. In such cases what happens? In such cases, carbon atom, it will neither lose the electron and will not accept the electron. Instead, it can share its electrons with the other atoms to get its stability. That means valency. What is the valency of carbon? It is 4. I can represent the electrons like this as dots, and these dots are called Lewis dots. Lewis dot symbols anta kariteve. Okay, and these 4 dots represents the 4 valence electrons of a carbon, and these 4 electrons are ready to involve in a mutual sharing with the other atoms. And what are those other atoms? Hydrogen. 4 hydrogens are the other atoms. You can take it as hydrogen, hydrogen, hydrogen and hydrogen. On hydrogen, I can represent them with a single electron. Single dot means what is the configuration of hydrogen? It is having a single electron. That is why it is represented with a single dot. Okay, this dot represents what? This dot represents the electrons. These 4 dots represents there are 4 electrons are there in the valence shell of carbon, and this 1 electron represents there is only 1 electron present in the valence shell of hydrogen. Okay, now these 4 electrons undergoes mutual sharing with the single electron of hydrogen, single electrons of hydrogen. Now count the number of electrons in carbon. Okay, here this bond is formed by the mutual sharing of both the atoms now. That means these 2 electrons, they belongs to both the atoms. They can belongs to either to hydrogen or to carbon. They belongs to both the atoms. Okay, here we look into the hydrogen. Usually hydrogen having 1s1 configuration, but after sharing this 1 electron with this 1 electron of a carbon, it will have 2 electrons. These 2 electrons responsible for both the hydrogen. That means it is having 2 electrons. That is why hydrogen attains the stability here. Duplet configuration followed by this carbon atom. These all 4 bonds are related to this carbon atom. That means each bond carries 2 electrons. How much electrons it is having? It is having 8 electrons. 8 electrons. 8 electrons andre enaitu? Again it will attain the octet configuration. Octet configuration anna carbon atom hondutte. Okay, this is the concept where the carbon atom, it is neither undergoes loss of electrons and nor it can gain the electron. Instead, it undergoes mutual sharing of electrons. By the mutual share of electrons with the other atoms, it will gain its stability. These are the 3 ways that the atoms undergoes stability, either by loss or by gain or by the mutual sharing of electrons. Now again we go with the octet rule. The definition is clear. Any atom, it in order to accept the stable electronic configuration, either it would lose, gain or mutual share of electrons can takes place. Okay, next we will move on to the now we have discussed regarding the octet rule, but this octet rule is not a universal rule. It is a universally accepted rule alla. It has also some limitations. What are those limitations? And we look into the limitations of a octet rule one by one. Limitations of octet rule. Okay, what will be the first limitation? Okay, according to the octet rule, ಏನು ಹೇಳಿದೀವಿ ನಾವು? In order to get the octet, ಯಾವ atoms ಗಳು, ಯಾವ molecules ಗಳು octet ಅನ್ನು ಹೊಂದುತ್ತೆ, ಅವುಗಳು ಮಾತ್ರ ಸ್ಟೇಬಲ್. ಯಾವ molecules ಗಳು 8 electrons ಅನ್ನು ಹೊಂದಿರುತ್ತೆ, ಅವುಗಳು ಮಾತ್ರ ಸ್ಟೇಬಲ್ ಅಂತ ಈ ರೂಲ್ ಹೇಳುತ್ತೆ. But the limitations told that molecules with, the first limitation, that molecules with incomplete octet, molecules with incomplete octet. ಕೆಲವು ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳು ಇನ್ಕಂಪ್ಲೀಟ್ ಆಕ್ಟೇಟ್ ಅನ್ನು ಹೊಂದಿದ್ರು ಕೂಡ ಸ್ಟಿಲ್ ದೋಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆರ್ ಎಕ್ಸಿಸ್ಟ್ ಅಂಡ್ ಸ್ಟಿಲ್ ದೋಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆರ್ ಸ್ಟೇಬಲ್ ಅಂತ ಫಸ್ಟ್ ಲಿಮಿಟೇಷನ್ ಹೇಳ್ತದೆ. ಸೆಕೆಂಡ್ ಒನ್, molecules with extended octet. Molecules with extended octet. Molecules with extended octet. Extended means those molecules which possess the number of electrons greater than 8 in their shell. They possess the number of electrons greater than 8. Even though they should not possess this octet rule, still those molecules are exist and still those molecules are stable in nature. That is explained by the second limitation. Okay, then the third one, the molecules with odd number of electrons. Some of the molecules which possess odd number of electrons, odd number of electrons. ಓಕೆ, ಇನ್ನು ಕೆಲವು ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳು ಆಡ್ ನಂಬರ್ಸನ್ನು ಹೊಂದಿರುತ್ತೆ, ನಾಟ್ ಈವನ್ ನಂಬರ್ ಈಕ್ವಲ್ ಟು 8 ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಹೊಂದಿಲ್ಲದೆ ಆಡ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಹೊಂದಿರುತ್ತೆ, ಬಟ್ ಸ್ಟಿಲ್ ದಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆರ್ ಎಕ್ಸಿಸ್ಟ್ ಆ್ಯಂಡ್ ಸ್ಟಿಲ್ ದಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆರ್ ಸ್ಟೇಬಲ್ ಅಂತ ಥರ್ಡ್ ಲಿಮಿಟೇಷನ್ ಹೇಳುತ್ತೆ. ವಿ ಕ್ಯಾನ್ ಗೋ ಥ್ರೂ ದಿಸ್ ಲಿಮಿಟೇಷನ್ ಒನ್ ಬೈ ಒನ್. ಫಸ್ಟ್ we will discuss with the first limitation, that is molecules with incomplete octet. Molecules with the incomplete octet. Example for this condition is if you take an example of BH2 beryllium hydride, AlCl3 aluminum trichloride, next boron trifluoride, BH3. These are the examples for the limitation of this octet rule that explains the molecules with the incomplete octet. Yeah, ee molecules galana consider ಮಾಡಿ. If we consider this molecule beryllium hydride, what is the atomic number of beryllium here? It is having atomic number 4. Okay, it is having the configuration 1s2 2s2 configuration ಅನ್ನು ಹೊಂದಿರುತ್ತೆ, 2 electrons in its valence shell. It is having 2 electrons in its valence shell. This is K shell, ground shell, and the next shell it is L shell. It will become a valence shell. It contains how many electrons? 2 valence electrons, and those 2 valence electrons ಅನ್ನು ನಾವು ಈ ತರ ಡಾಟ್ಸ್ ಅಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಬಹುದು. These dots represents the valence electrons in this beryllium. How many valence electrons are there? 2 valence electrons are there na. Okay, these 2 electrons which combines with the 2 hydrogen atom. Hydrogen atom alli electron eshtirtade? It is having only 1 electron. Here also which possess only 1 electron, and there is a bond formation takes place between the 1 electron of hydrogen and 1 electron of this atom. Then now count the number of electrons present in the both the atoms and the number of electrons present in the central atom. Here the central atom beryllium which possess how many electrons here? As we already told that these 2 bonds, okay, these 2 bonds, here the electrons present in these 2 bonds are responsible for both the atoms anta helidvalva. Adhe tara this beryllium is bounded by 2 atoms or 2 bonds. That means these 2 bonds multiplied by 2, that means 4 electrons. This beryllium is having 4 electrons, 4 electrons, and these 4 electrons is not equal to 8. Octet rule ಗೆ ಹೊಂದುತ್ತಾ ಇದು. ಇದರಲ್ಲಿ ಸೆಂಟ್ರಲ್ ಆಟಮ್ ಅಲ್ಲಿ 8 electrons ಇಲ್ಲ, ಆದರೂ ಕೂಡ ಈ ಮಾಲಿಕ್ಯೂಲ್ ಎಕ್ಸಿಸ್ಟ್ ಇರ್ತದೆ, and still this molecule is stable in nature. This is the first limitation of octet rule. Even though the molecules which possess the incomplete octet, they still exist and they stable in nature. Okay, here hydrogen atom possess a duplet. This hydrogen atom possess a duplet configuration, but this beryllium atom which consists of 4 electrons which do not possesses the octet rule. Even though which do not possesses the octet rule, which is stable molecule and which is still existed molecule. Okay, this is the first example, and the second example, one more example you can take, aluminium chloride. What is the atomic number of aluminium here? 13. It is having the configuration aluminium it is having the configuration of 283. It is 283 configuration. Do you understand this? 28 K shell, L shell, M shell. In the last valence shell, it consists of how many electrons? It consists of 3 electrons. 3 electrons means we can represent those 3 electrons like this na, by 3 dots. One dot represents first electron, second dot, third dot represents the another 2 electrons. These 3 electrons are represented as 3 dots. These are called Lewis dots. Okay, next this Cl atom. Another one is a chlorine atom. Atomic number is 17. It is having a 287 configuration. That means this each chlorine atom which possesses how many electrons? Each chlorine atom which possesses 7 electrons in their valence shell. That is why each chlorine atom, I can write it here, aluminium, it is having 3 valence electrons, and Cl, this atom will possess how many electrons? It possesses 7 electrons in their valence shell, 2, 4, 6 and 7. This chlorine atom also possesses 7 electrons, and one more chlorine atom which possesses 7 electrons. This chlorine atom requires how many electrons? It requires 1 electron. And this chlorine atom requires, all these 3 requires 1 electron to get the stability. But during the formation of a bond, after the formation of bond, all these chlorine atoms get 8 electrons. 6, 2, 4, 6 plus 2, 8, 2, 4, 6 plus 2, 8, and 2, 4, 6 plus 2, 8. All these chlorine atoms will get 8 electrons and they exhibit the octet rule. But this central atom aluminium, which is attached with 3 chlorine atoms by 3 bonds, that means the number of electrons here are 3 to 6 electrons, and these 6 electrons not equal to 8. That means it is not equal to octet. Okay, this is the limitation of first limitation of octet rule, that shows that even though the atoms which do not possess the 8 electrons in their outermost shell, still those molecules are exist. Okay, this is the first limitation of octet rule. Okay, what will be the second limitation of octet rule? Second limitation of octet rule tells us that molecules with extended octet, molecules with extended octet. Okay, some of the molecules, if we consider an example of a PCl5, SF6, H2SO4, if we consider these examples, these compounds which possesses more than 8 electrons, even though they possess more than 8 electrons, the molecules are still exist and molecules are still stable. But according to the octet rule, what it says means those who get octet configuration, they are only stable in nature. But if you consider this PCl5, what is the atomic number of potassium here? Potassium, it is having the configuration 285 configuration. In the valence shell, it consists of 5 electrons. Okay, those 5 electrons, we can represent those 5 electrons like this. Those 5 electrons like this. These 5 dots represents the 5 electrons, 5 valence electrons present in the valence shell of phosphorus anta ಹೇಳ್ತದೆ. Okay, followed by 5 Cl atoms, Cl, fluorine atoms. All these atoms which possesses how many electrons? Each possesses 7 electrons. Each Cl atom possesses how many electrons? 7 electrons. 2, 4, 6, 2, 4, 6, 7, 2, 4, 6 and 7. These can represent the number of valence electrons present, and these 5 dots also represents the number of valence electrons present. And after the bond formation, this phosphorus, it is in a bond with the 5 Cl atoms. Okay, then these one bond represents 2 electrons. Total we have 5 bonds. That means the central atom phosphorus, it is having 10 electrons. It exceeds the octet rule. Octet agabekantandre it should possess 8 electrons only, but here it can possess more than 8. That means it possesses 10 electrons. The central atom should possess 10 electrons. Even though it possesses the 10 electrons, still this molecule is exist. PCl5 molecule is exist, and this is a stable molecule. Okay, like that, this is the second limitation of octet rule, that tells us that molecules with extended octet also exist in nature and they are stable in nature also. Okay, if we can take the one more example, that is SF6. You can take, if you take an example of SF6, it is having the configuration sulfur atom which possesses 6 electrons in its outermost shell. Okay, and fluorine atoms which possesses 9 electrons, as it belongs to halogen group. All the halogens which possesses 777 electrons in their valence shell. After the formation of a bond, this sulfur atom, it is attached with how many bonds? It is with a total 6 bonds, and which possesses in total 12 electrons. It is having 12 electrons. It is not equal to 8. It possesses more than 8 electrons. Even though it possesses more than 8 electrons, this molecule is exist. Okay, again this is against the octet rule, and this will become the second limitations of this octet rule. Okay, according to this rule, molecules with extended octet, those molecules which do not possess the 8 electrons and they possess more than 8 electrons also exist, and they are also stable in nature. And explain. Okay, next, the third limitation of octet rule. What it says? Molecules with odd number of electrons. Okay, odd number of electrons. If you take an example of nitrogen oxide, NO, here, what is the atomic number of nitrogen here? It is having 7, nitrogen 7. Okay, its configuration is a 2, 5. It is having in the valence shell. It consists of how many electrons? It consists of 5 electrons, and the nitrogen we can represent like this: 2, 4 and 5. These 5 dots represent 5 valence electrons of nitrogen, followed by this oxygen atom. Atomic number of oxygen is 8, and it is having a 2, 6 configuration. That means in the valence shell it consists of how many electrons? It consists of 6 electrons, and I can represent these 6 electrons like this. These 6 dots around this oxygen atom, which represents the 6 electrons are present in the valence shell. Right. Next, there is a bond formation takes place between this nitrogen and oxygen atom. After that, this oxygen atom, now count the number of electrons here. 2, 4, 6, 8. Here oxygen atom should possess 8 electrons, but now count the number of electrons for nitrogen. If we consider it 2, 4, 6 and 7. Here nitrogen possesses 7 electrons and oxygen possesses 8 electrons. Here oxygen which follows the octet rule here, but the nitrogen which possesses odd number of electrons which is not equal to 8, but still this molecule is going to be exist. Okay, this molecule is exist and is stable in nature. Okay, even though which do not possesses the 8 electrons, this molecule is exist and which possesses the odd number of electrons. That will become the third limitation of a octet rule. With this you can take this example also, nitrogen dioxide also you can take. This also is the same way. Here also the nitrogen will get odd number of electrons and which is against the rule of octet. Okay, next. In addition to this, not only these concepts, this octet rule which does not account for the relative stabilities of the molecule, that means which do not explains the stabilities of the molecules, and the next one, this octet rule which does not account for the shape of the molecules. Okay, these are all the limitations of a octet rule. Okay, what are those limitations? Molecules with the incomplete octet also exist in nature, that is the first limitation. Second one, molecules with the extended octet, even though the molecules which possess more than 8 electrons also they can exist in nature. And the third one, molecules with odd number of electrons, that means some of the molecules even though which possesses odd number of electrons and which is not equal to 8, still those molecules are exist. That will be the third. And molecules and this octet rule which does not account for the shape of the molecule, that will be the limitations of this octet rule. Is it clear? Next, we will move on to the classification of this chemical bonding. classification of chemical bonding. Okay, this chemical bonding which majorly classified into two categories. That is, the very first one, it is interatomic chemical bonds. Interatomic chemical bonds. The next one, it is intermolecular chemical bonds. Intermolecular chemical bonds. Okay, interatomic chemical bonds followed by intermolecular chemical bonds. Okay, as it in the name itself indicating that this bonds, this specially chemical bonds which is formed in between the atoms, this is interatomic chemical bonds. That means here the bond formation takes place in between the atoms, and in case of this, here the bond formation takes place in between the molecules. These are the bonds in which takes place in between the molecules. These are the molecular bonds, and this is the interatomic chemical bonds. And further, these interatomic bonds can be classified into ionic bonds, covalent bond, coordinate bond, covalent bond ಅಂತ ಕರೀತಾರೆ. covalent bond, ಇದನ್ನ dative bond ಅಂತಾನೂ ಕರೀತಾರೆ. And the last one is a metallic bond. Okay, these are all the types of interatomic bonds. Okay, interatomic bonds are further classified into ionic bond, covalent bond, coordinate covalent bond, or else it can call it as a dative bond also, and the last one is a metallic bond. Okay, here The intermolecular chemical bonds are also classified into van der Waals forces, van der Waals forces, followed by hydrogen bonds, followed by hydrogen bonds. Okay, here this hydrogen bonds further classified into intramolecular, and intermolecular. Okay, these hydrogen bonds are further classified into intramolecular hydrogen bond and intermolecular hydrogen bond ಆಗಿ ಮತ್ತೆ divide ಆಗ್ತದೆ. Okay, here the classification of chemical bonding. These chemical bonds can be classified into two categories. First one, it is interatomic chemical bonds. That means here the bonds take place in between the atoms. Another one, it is intermolecular chemical bonds, where the bond formation takes place in between the molecules. Here this interatomic chemical bonds are further classified into ionic bond, covalent bond, coordinate bond and metallic bond. And this intermolecular chemical bonds are further classified into van der Waals forces, followed by hydrogen bonds, and then this hydrogen bond is further classified into intramolecular hydrogen bonding, followed by intermolecular hydrogen bonding anta matte divide ಆಗ್ತದೆ. Okay, here when we compare the strength of these two bonds in between the interatomic chemical bonds and intermolecular chemical bonds, here this interatomic chemical bonds, which includes the electrons, here the availability of electrons, these reactions which involves the electrons, means these reactions which involves the electrons, at the same time these intermolecular chemical bonds which do not involves electrons, that means here the bond formation is not takes place here. Okay, these are all the type of bonds which do not involves the formation of bonds, that is why which do not involves the electrons at this stage. Interatomic chemical bonds which strongly involves the involvement of electrons takes place here. That is why if we compare the strength of interatomic chemical bond with the intermolecular chemical bond, interatomic chemical bonds are stronger bonds than intermolecular chemical bonds, because which involves the involvement of electrons rather than this which do not involves the electrons. With the involvement of electrons, they will become a stronger bonds, is of the order of 200 to 400 kilojoule per mole. Okay, the energy of this molecule, means the bond strength of this bonds is of the order of 200 to 400 kilojoule. It is of the order of 2 to 200 kilojoule per mole. Okay, when we compare the strength of interatomic bonds with the strength of intermolecular bonds, because of the involvement of electrons, interatomic chemical bonds are stronger than intermolecular chemical bonds, where the availability of electrons at this stage is not possible. They do not involve the electrons in their reaction. Okay, these are the classification of a chemical bond, which can be classified into two categories: interatomic followed by intermolecular, and these two are further classified like this. Okay, next we will move on to the interatomic chemical bonds. Interatomic chemical bonds, that is the very first interatomic chemical bond, that is ionic bond, or ionic bonding also you can call it, ionic bond. Okay, you just go through this ionic bond by taking a suitable example. During the formation of NaCl molecule, this is the best example to explain this concept. Okay, during this you can take this sodium chloride as an example. During the formation of this molecule, formation of formation of NaCl molecule. Formation of NaCl molecule. Okay, first you can take sodium atom. What will be the atomic number of sodium atom? Again, it is 11. It is having the configuration of a 1s2, 2s2, 2p6 and 3s1 it is. It will be the configuration of sodium. Okay, here 1s2 represents K shell, 2s2 and 2p6 represents L shell, followed by the 3s1 which represents the M shell, and it will become the valence shell of a sodium atom, where this valence shell which consists of how many electrons? Which consists of only one electron it is. Okay, which consists of one electron, such that this sodium atom, it is always ready to donate this one electron. Why the atoms are ready to donate the electrons? As we already told that atoms, they are ready to donate, accept or share the electrons only to get the stable electronic configuration. ಯಾವಾಗ ಸ್ಟೆಬಿಲಿಟಿ ಕಡೆ ಹೋಗಬೇಕಾಗಿರುತ್ತೆ ಆವಾಗ ಆಟಮ್ಗಳು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ಬಿಟ್ಕೊಡ್ತವೆ ಅಥವಾ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ಗೇನ್ ಮಾಡ್ಕೊಳ್ತವೆ. ಓಕೆ, ಹಿಯರ್ ಇನ್ ಆರ್ಡರ್ ಟು ಗೆಟ್ ದ ಸ್ಟೇಬಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್, this sodium atom, it loses its one electron, it ready to lose its one electron. Okay, here this is the atomic structure of a sodium atom. This is the nucleus. This will be the first shell, that means this is the K shell, L shell this is, and this will be the last valence shell, that is M shell. K, L and this is M shell. In the first shell, which consists of how many electrons? Which consists of only 2 electrons. We can represent like this, 2 electrons, the first shell which consists of, and the L shell, second shell, which consists of how many electrons? Which consists of total 8 electrons. 4 plus 3, 8 electrons it is. And the last shell, the valence shell, M shell, which consists of how many electrons? Only 1 electron, which consists of only 1 electron in its valence shell. Okay, that is why this electron from this nucleus, which is less tightly held by the nucleus. Okay, that is why in order to attain the stable electronic configuration of 2,8, this electron is always ready to remove from this shell. Okay, after the removal of this electron from sodium atom, the atomic structure becomes like this. The atomic structure of a sodium atom should like this, which consists of, as it is, first shell K shell 2 electrons, second shell L shell which consists of 8 electrons, and the removal of complete shell takes place with the loss of this one electron. ಈ electron loss ಆದ್ಮೇಲೆ M shell ಅಲ್ಲಿ ಯಾವುದೇ electron ಇರೋದಿಲ್ಲ, ಹೋಗಿಬಿಡುತ್ತದೆ, followed by this electron removal takes place and this becomes a sodium ion. Okay, here in this sodium ion, what is the configuration of sodium ion here? After losing this one electron, it will attain a stable configuration of 2,8, right? What is the configuration of sodium atom where one electron is still present in this shell? It is having the configuration of 2,8,1 it is. Okay, before the loss of electron, it is having a 1 electron in this valence shell. After this loss of 1 electron, it will become this configuration and it will become as a sodium ion. That means Na plus state will be the stable state of a sodium atom. In order to attain the stable electronic configuration, sodium atom, it loses its 1 electron, Na plus 1 electron, to get stable electronic configuration. Here this sodium atom should possess a 2,8 configuration. That is why this is the stable state. Okay, likewise, if you take an example of chlorine atom where it is having atomic number 7, and I can represent its electronic configuration like this 287 it is. Okay, 287. Okay, in the valence shell, which consists of how many electrons? In the valence shell, it should possess 7 electrons. It consists of 7 electrons in the valence shell. Okay, this is the orbital or atomic structure of a chlorine atom. First, which consists of 2 electrons, second shell as it is, which consists of 8 electrons, and followed by the third, which consists of 7 electrons, Okay, this third shell, which already filled with 7 electrons, and this into this third shell, we require how many electrons here? In order to get the stable electronic configuration, we need to have one more electron. That is why this Cl atom is always ready to accept that one more electron. This is chlorine atom. After accepting that one more electron, it will become like this. It will become last 7 electrons iddiದ್ದು. After the addition of 1 electron, it will become 3, 6 and 8. It will become 8 electrons. Now this shell is completely filled. This is the chloride ion. Okay, Cl, atomic number 17, having the configuration 287. It requires one more electron. Due to the formation or due to the requirement of one more electron, just we have wanted to add one more electron. It can gain one more electron. That electron will add it into this shell, and it will become what? Cl minus, where its configuration is a 288. 288. Okay, andre Cl minus is the stable state now. Here Na plus, after losing this electron, it will attain the stable electronic configuration. Now it is positively charged, it is negatively charged, and these oppositely charged ions are attract each other by Na plus Cl minus. We are going to have NaCl. These oppositely charged ions, they are attract each other by electrostatic force of attraction. Okay, oppositely charged ions attract each other by which force? It is electrostatic force, which holds oppositely charged ions together. These oppositely charged ions, which are attracted by electrostatic force of attraction, and this is, we can call it as ionic bond, and the resulting bond between these two is known as a ionic bond. Okay, or the definition of ionic bond, we can call it as, it is an electrostatic force of attraction which holds oppositely charged ions together. Ee taranadru ನೀವು represent ಮಾಡಬಹುದು. The definition of ionic bond, or the bond which is formed by the complete transfer of electrons, valence electron, from the valence shell of one atom to the valence shell of another atom. Here sodium loses its one electron. That one electron is gained by this Cl minus. With the loss of one electron, sodium becomes stable. With the gain of one electron, Cl becomes stable. Alvendri, here we can define this ionic bond as the bond which is formed by the complete transfer of electron from the valence shell of one atom to the valence shell of another atom. That is called a ionic bond. Okay, ionic bond ಅನ್ನು ಎರಡು ತರ ಪ್ರೊನೌನ್ಸ್ ಮಾಡಬಹುದು. First one, it is the electrostatic force of attraction which holds these oppositely charged ions together, and the bond resulting is we known as a ionic bond. And the second definition, the bond which is formed by the complete transfer of electron from the valence shell of one atom to the valence shell of another atom. Illi valence shell of sodium atom inda valence shell of ಕ್ಲೋರಿನ್ ಆಟಮ್ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಹೋಗಿದೆ. ಯಾಕೆ ಅಂದರೆ ಸೋಡಿಯಂ ಅಲ್ಲಿ 1 ಎಲೆಕ್ಟ್ರಾನ್ ಎಕ್ಸಸ್ ಇದೆ and chlorine it requires 1 more electron. Okay, that is why here the sodium donate that 1 electron to become stable. At the same time Cl minus which is ready to accept that electron to get stable, and the force of attraction which holds these positive oppositely charged ions is called what? The electrostatic force. Okay, the definition of ionic bond is the electrostatic force of attraction which holds oppositely charged ions together. Okay, followed by the bond which is formed by the complete transfer of electrons from outermost shell of one atom to the outermost shell of another atom, or from valence shell of one atom to the valence shell of another atom. This is, we call it as a ionic bond. Okay, now in order to form the ionic bond certain conditions should be there. ಕೆಲವು conditions ಇದೆ ionic bond formation ಆಗಲಿಕ್ಕೆ. What are those conditions? If you take an example of NaCl, here it is an NaCl. Okay, here Na is a metal, Cl is a non-metal. That is the first condition. In order to form the ionic bond, the added species in which the one should be a metal and another should be non-metal, ionic bond formation takes place in between a metal and a non-metal. Metal ಮತ್ತೆ non-metal ನಡುವೆ ionic bond formation ಆಗುತ್ತೆ. First one. Second thing, here there is a bond formation takes place. Okay, both the atoms are having a separate electronegativity difference. Electronegativity difference ಅಂದ್ರೆ ಗೊತ್ತಾಗ್ತದೆ, it is the ability of an atom to attract the shared pair electrons towards itself. That is the electronegativity. ಒಂದು atom ಇನ್ನೊಂದು atom ಇಂದ electrons ಅನ್ನ accept ಮಾಡೋ capacity ನಾವು electronegativity ಅಂತ ಕರಿತೇವೆ. Where in order to form an ionic bond, the electronegativity difference between these two atoms should be greater than 1.7. ಈ ಎರಡು ಆಟಮ್ಗಳ ನಡುವಿನ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಡಿಫರೆನ್ಸ್ ದಟ್ ಶುಡ್ ಎಕ್ಸೀಡ್ಸ್ ಮೋರ್ ದೆನ್ 1.7. 1.7 ಗಿಂತ ಜಾಸ್ತಿ ಇದರದು ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ ಇದ್ರೆ ದೆನ್ ಇಟ್ ಈಸ್ ರೆಡಿ ಟು ಫಾರ್ಮ್ ಅ ionic bond. Okay, which is the first condition here. The atoms involved in the bond formation in which one atom should be a metal, another atom should be a non-metal, and the second one, the difference in the electronegativity between the combining atoms should be greater than 1.7 it is. Okay, then after the loss of electrons, this metal atom becomes cation. This metal atom becomes cation. Sodium atom irodu sodium ion agi convert agide. This is a cation. Then after gaining the electrons, this non-metal gains the negative charge and it will become anion. Here this will be the chlorine atom. After gaining that one electron, it will become a chloride ion. Chloride ion agi convert agtade. It is having negative charge, that become a anion. Okay, these are the conditions for the formation of a ionic bond. Okay, then okay, the factors favorable for the formation of a ionic bond, that we will discuss it in the next class. Okay, thank you.